Welcome to the InterSystems Kubernetes Operator, version 3. My name is Stephen Lubars, and I'm a developer in the Data Platforms group at InterSystems. My current focus is on deployment of Iris in the cloud, including containers, the InterSystems Cloud Manager, and the subject of this talk, the InterSystems Kubernetes Operator.
This talk assumes some familiarity with Kubernetes and the InterSystems Kubernetes Operator, so if you're unfamiliar with either, you might want to supplement this talk by watching some of our other introductory videos on those topics. I'm going to go over some of the changes and additions in version 3. Then we'll walk through a cluster definition using some of those new version 3 constructs. And finally, we'll deploy an Iris cluster using version 3. The first change I wanted to talk about is the addition of ephemeral volume definitions to the resource definition. IKO was already able to deploy persistent volumes, which have a lifetime outside that of the pod for critical things like your data. Ephemeral volumes come and go with the pod itself. They're mounted on a temporary file system, typically reside in RAM, and are good for staging files such as config maps or secrets. IKO is now able to deploy the InterSystems Web Gateway container. One can specify a number of replicas, the Docker image, the server type, Apache, Nginx, or Apache Lockdown, which is the subject of another talk, an array of application paths, and the algorithm for remote server selection, which could be failover or load balancing. IKO can now deploy the InterSystems API Manager. This requires specification of the container image, as well as a license key secret which contains a Kong license. And here's an example of creating a generic Kubernetes secret containing a Kong license. IKO can now deploy Iris system alerting and monitoring. One need only provide the container image. IKO will then configure system alerting and monitoring for all of the Iris instances in your cluster. IKO now deploys mirroring in SSL mode by default. One is responsible for staging SSL certificates in each pod at the directory under Irissys SSL. This is controlled by the CPF merge file generated by IKO. If you want to disable this feature, which we don't recommend, one can override the CPF merge in the user-defined data.cpf file, set mirror SSL dir to the empty string, and add the CPF file to the config map. IKO is already capable of detecting a couple of reserved config maps, data.cpf and compute.cpf. We've now added a third one, common.cpf. These will be parameters and overrides that apply to all of the Iris nodes. For example, this might be where you put your password hash if you want your data and compute nodes to have the same password. These config maps are processed in the following order. First, the config maps generated by IKO itself, then user overrides in the common CPF file, and then finally user overrides in the data CPF or compute CPF files, which are applied to data and compute nodes respectively. And here's an example command for creating a config map with all three CPF files in it. the password hash field has been removed from the IKO CRD. The reason being that one can already specify this inside the CPF merge file using parameter password hash in the startup block. So to be consistent with how other iris-specific parameters are provided, one should put this into one of the CPF files, for example, common CPF, and then add this to the config map supplied to IKO. And here's an example command for doing that. Previously, every cluster deployed by IKO was a sharded cluster. Even if it only contained a single instance, it was a shard of one. With this change, sharding is not enabled or configured unless the sharding parameter with a non-zero count is supplied in the CRD. This actually creates some subtle changes in how we define what a data and compute node is. In the non-sharding configuration, the compute nodes will actually become pure ECP clients, effectively allowing one to do a traditional non-sharding iris installation. If one later enables sharding, then the existing cluster will be converted to a sharded cluster, and the compute nodes will be changed into sharding compute nodes. The default load balancer provided with IKO, which provides access to the super server port and the management portal, used to point unconditionally at the first iris instance in the cluster. It is now mirror aware. We've modified the arbiter to continuously monitor and label the pod containing the mirror primary. And then the selector on the load balancer filters on that label and directs all traffic to the current mirror primary. Okay, let's do a demo. I'll be doing this demo using Google Kubernetes Engine. Let's have a look at the CRD. The license key secret contains a Kong license, which will allow us to deploy the InterSystems Application Manager. In the config source, we've added the CPF merge file containing the password hash with the iris password. We've added an ephemeral volume to stage SSL certificates. We don't recommend doing this in production, and that alternative, more secure, possibly third-party mechanisms be used to do this, but it will suffice for the purposes of this demo. And here, in the data node definition, you can see where we mount those SSL certificates. Here's the new Web Gateway container. I've provided an application path here that we should be able to see inside the Web Gateway portal. Here's the new InterSystems Application Manager definition, and here's the system alerting and monitoring definition. All right, so let's go ahead and start the operator itself. I'm going to wait until we see that that's up and running with a readiness status of 1 out of 1. There it is. And now we'll apply this CRD. This will take a few minutes, so I'm going to take the liberty of fast forwarding. Okay, and we are up and running. Let's take a look at some of these. First, we'll look at the Iris Management Portal. We'll take a look at the mirror monitor, where you can see we have the primary and the backup, the arbiter, and if I go into mirror settings, we can see that we're in SSL mode. Next, let's take a look at the IAM node. And we see that's up and running. Let's look at system alerting and monitoring. We see that's up and running. It's been configured to monitor all of our data and compute nodes. That warning you see came from the backup trying to join the mirror, but that's going to disappear soon because as you saw, the configuration actually did complete successfully. And finally, let's take a look at the Web Gateway. We can look at application access, and here we see the VS 2021 application path we added. Under server access, we see that it configured access to the compute nodes, which is the preferred configuration when they are present. Let's add some passwords there. Test the connection, and that succeeds. Okay, and that concludes the demo. We reviewed a new volume type, several new node types. We defined a cluster including these changes, deployed it, and with the addition of system alerting and monitoring, saw how one could monitor this cluster. I suggest you also attend the talk InterSystems Iris Container Updates. It goes into a lot more depth on some of the changes to our containers, in particular the Web Gateway container and the Apache locked down mode.
If you want to connect with me, my name is Stephen Lubars, and I can be reached at stephen.lubars@intersystems.com.